Hey y'all, it's me, Miss B. Today we're graphing absolute value functions. So go ahead and define what an absolute value is. You should have said an absolute value is a number's distance from zero. The axis of symmetry is a line through an object so that both parts are reflections of each other. And then a vertex is a common point between segments. So if I'm just going to draw a picture. This is a parabola. But down here, this is the vertex. That's that low point, that common point between segments. And then this line that goes through it, that is the axis of symmetry. So if we graph one side of our absolute value, we know how to graph the other side. So let me erase this stuff over here. So if I have these values and I plug them into my absolute value, I should get my graph once I plug these in. So I'm going to plug -2 into the equation, and this is the equation right here. I just put it right here. Plug -2 in, and I get a 2 out. So -2, 2 is that point. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So you'll notice it makes a V shape. Something else I want you to note is that this line right here, that is the axis of symmetry right there. It's invisible, but it cuts it in half. It's equal on both sides. And then this point right here at the bottom, that is our vertex. Okay, so our vertex is going to move around based on our points, and our axis of symmetry might move around based on points as well. But for the most part, if we graph one half of it, then we're graphing the other half. I also want you to notice that if I were to block off this part of my graph, maybe, it's just a line. But then because of the axis of symmetry, we get both parts. So this is just a line. It's basically the line y equals x. But then we have y equals -x on the other half here, but it just doesn't go down into the negative area down here. So that's going to help us graph a little bit. All right, so this is a parent function. This is the starting point for all absolute value equations. All right, so here we have y equals -x. You should notice that we have a negative here. Therefore, this is going to cause a reflection over the x-axis of our parent function. So I'm taking this graph over here and reflecting it over the x-axis, which is right there. Let's go ahead and reflect those points. So I've got 0, 0 staying, and then each of these points gets reflected over. And so I'm easily able to graph that based off of the parent function. Now, you can plug it in to this graph, but it does make your life a little bit harder. So plug in only when you need to check. So let's say I just want to check it. I would plug -2 in, so I do negative absolute value of -2, and that gives me -2, and -2, 2 is this point right here, so we're good. All right, let's look at these graphs here. So what is the graph of the absolute value of y equals the absolute value of x minus 4? Go ahead and answer why this graph is different from the parent function. So you should have said that it moves the parent function down four units, because it's -4 outside the absolute value. So it's moving it down 4. Again, if we think about it, it's a slope of 1, so I'm going to go up 1 over 1 and graph that positive line. And then it gets reflected over that axis of symmetry, and so we're able to get what the other half looks like fairly easily. All right, next up, we've got -x plus 2. What are the transformations? You should have said a reflection over the x-axis and then up 2. So we're going to take our graph and reflect it over the x-axis and shift it up 2. So it normally looks like this. So we want to reflect it and then move it up 2. So this point, this is what the reflection is going to look like. It's going to get reflected over here, and then it's going to move up 2 units. So this point is now here. Oop. Our vertex, when it gets reflected, it's going to become 0, and then it moves up 2, so it's 2. And as is this one. So we can see more clearly now that it's been reflected and then shifted up 2. So it should be a downward V shifted up 2. So if you didn't want to go from your starting point, I would think, okay, well, I know it's going to look like an inverted V like this, but it's not going to be at 0, 0. It's going to be shifted up 2. So I'm going to go up 2 and then do my negative slope, which is -1. So down 1 over 1. Graph that line and then reflect it over the x-axis, or I'm sorry, the y-axis, because that is our axis of symmetry. So there is that. All right, for this next one here, what are the transformations? You should have said left 2 and up 3. So I'm taking that vertex, which was usually 0, 0, and I'm going left 2 and up 3 with it. So this is my new vertex. My slope is up 1 over 1. So I graph that. And then this is my axis of symmetry, so I'm going to reflect it over. There's that. So if we know those transformations, our graphs are that much easier to draw. Okay, again, if you don't know how to do the transformations, you always have the table as a fallback. That's it for today, folks.